Hi children, welcome to maths classes. Children, today let's discuss about irrational numbers in the chapter number systems. Children, what are irrational numbers? Before that children, do you know what are rational numbers? You all know, right? Rational numbers are the numbers which can be expressed in the form of P by Q and Q not equal to 0. Here Q should not be equal to 0. These numbers which can be written in the form of P by Q and where Q not equal to 0 are called as rational numbers. Now irrational numbers are just the opposite of rational numbers. That means the numbers which cannot be expressed in the form of P by Q are called as irrational numbers. Irrational numbers are just the opposite of rational numbers. Numbers which are not rational numbers are nothing but irrational numbers. These numbers cannot be expressed. in the form of P by Q. Such numbers are called as irrational numbers. Do you know the examples of rational numbers? Can you tell that? 2 by 3. Minus 5 by 6, 7 by 8, even the number 9, it is also a rational number. It can be expressed as 9 by 1, so it is also a rational number. But what are irrational numbers? These irrational numbers cannot be expressed as a form of P by Q. Examples: root 2, root 3, root 5, root 11, root 13, pi, like 0.110112 and so on. This number does not end at all. All such numbers are called as irrational numbers. The proofs how these numbers are called as irrational, you learn that proofs in 10th class children. Now remember, the numbers which cannot be expressed in the form of P by Q are called as irrational numbers. These numbers, root 2, root 3, root 5, root 11, root 13, root 15, root 17, all these numbers cannot be expressed in the form of P by Q children. Pi, you all know, right? Pi means 22 by 7. All these numbers are some examples of irrational numbers. Children, you know that there are different types of numbers, right? Natural numbers, whole numbers, all those numbers you know. We considered one box before. Do you remember in the previous class we considered a box? See, if 1, 2, 3 and so on numbers are there, you call this box as box of natural numbers. If numbers 0 is also included in this box, then you call this box as, if only 1, 2, 3 is included, you call it as natural numbers. If 0 is also included, you call it as whole numbers. If negative numbers minus 1, minus 2, minus 3 and so on are included, negative numbers, 0, positive numbers, then you call it as box of integers. Integers are represented by symbol Z. If the numbers in the form of fraction, that is the numbers in the form of P by Q are included, 1 by 2, 5 by 6, minus 7 by 8, etc., then the numbers are called as, these numbers are called as rational numbers. Then this box will become set of rational numbers. Rational numbers are represented by letter Q. Now children, if numbers like root 2, root 3, pi, what are these numbers children? Yes, these are irrational numbers. If these irrational numbers are also included in this box, so natural numbers, whole numbers, integers and irrational numbers, rational numbers, if all these are included, then this box is called as box of real numbers. So children, real numbers means they include rational and irrational numbers. So real numbers means numbers are all numbers children. Rational, irrational. Rational means in that only you get natural numbers, whole numbers, integers, everything. Irrational means numbers which are not rational. Root 2, root 3, pi and so on. If all these numbers are included, then this whole set is called as real numbers. Children, you all know that natural numbers are infinite, whole numbers are infinite, similarly rational numbers are infinite. In the same way, irrational numbers are also infinite, children. You can't tell root 2, root 3, root 5, only these are irrational. There are many and many. There are infinite irrational numbers. So, in the whole you can say that real numbers are also infinite. Real numbers are also infinite. Children, all these numbers, each rational number, that means not only 1, 2, 3, half, 1 by 2, these can be represented in the number line, children. Irrational numbers are also, they also can be represented on the number line. So all the real numbers can be represented on the number line, and each and every point on the number line is a number, is a real number, children. All the numbers on the number line are real numbers, and each and every real number, that means any number can be represented on the number line. So children, now you understood irrational numbers, children. Irrational numbers are nothing but opposite of rational numbers. That means irrational numbers cannot be expressed in the form of P by Q. Those are called as irrational numbers, and rational numbers and irrational numbers together they are called as real numbers. All these numbers are infinite, children, and every real number means all the numbers are called as real numbers, and every real number can be represented by a point on the number line. Children, Pythagoreans in Greece are the people who discovered irrational numbers, children. Who are Pythagoreans, children? These people are the followers of great mathematician and philosopher Pythagoras, children. You all know about Pythagoras, right? He gave us Pythagoras Theorem. What is Pythagoras Theorem, children? In a right angle triangle, this is a right angle triangle, A, these sides are A, B and C. How do you get C? C is equal to root of A square plus B square. That is square of hypotenuse. Hypotenuse is this. Square of hypotenuse is equal to the sum of the other two sides. This is Pythagoras theorem. The person who gave this is Pythagoras, and Pythagoreans are the followers of Pythagoras, children. These people are the first people who discovered irrational numbers. What are irrational numbers? A number, suppose S, is called an irrational number if it cannot be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. What are irrational numbers, children? Any number, yes, is called irrational if it cannot be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. That means the numbers which are not rational are called as irrational numbers, and Pythagoreans are the people who first discovered irrational numbers. Children, we all understood that real numbers means rational numbers and irrational numbers. You all know that, right? Real numbers means they are nothing but rational numbers and irrational numbers. Okay, children. Now, you also know that every number, that is every real number, can be represented by a unique point on the number line. That is what? Every real number can be represented by a unique point on the number line. Based on this statement, children, let's solve example 3 in your chapter number systems. What is the question, children? Locate root 2 on the number line. What is root 2, children? Irrational number. You know that, right? This cannot be expressed in the form of P by Q. Now, let's locate this root 2 on a number line. Draw a number line, children. Let's draw a number line. 0, 1, 2. Here also minus 1, minus 2. This point root 2 can be represented using Pythagoras theorem. On the number line, we can represent root 2 using the Pythagoras theorem, children. From point 0, this is 0 and this is 1. Now, what is the Length of this children 0 to 1, it is 1 unit. It is 1 unit. Draw a perpendicular line from 1 and the length of that should be 1 unit. From 0 to 1 it is 1 unit and draw a perpendicular line from 1. Draw a perpendicular line. Perpendicular means 90 degrees. What should be the length of that line? Perpendicular line. Its length should be 1 unit, children. Okay. Now, children, join the point. Join the end point. This end point and 0. From 0, join it, children. From 0 to 1, it is 1 unit. Now, second step is draw a perpendicular line at 1. At point 1, draw a perpendicular line of length 1 unit. Now, join point 0 and this, what will be this, children? If it is a graph, it will also be 1 unit. On y-axis, if you point, it will be 1 unit. If this is a graph, this is y-axis. At y-axis, it will point 1 unit. So, join this dot and point 0. Now, what is the shape, children? This is a right angle triangle. You all know, right? Right angle triangle. If one side is 1 unit, another side is another 1 unit. What will be the length of hypotenuse, children? What will be the length of hypotenuse? H is equal to root of side 1 square plus side 2 square. Opposite side square plus adjacent side square. H is equal to root of opposite side square plus adjacent side square. One side is 1 unit, another side is 1 unit. 1 square plus 1 square is 1 plus 1. That means hypotenuse is root 2. So, one side is 1 unit, that is adjacent side is 1 unit and opposite side is 1 unit. Then you get hypotenuse as root 2. You know that hypotenuse square is equal to opposite side square plus adjacent side square. This is Pythagoras theorem. According to this Pythagoras theorem, you got hypotenuse as root 2. Here also same, children. This is 1 unit. This is 1 unit. Opposite side is 1 unit. Adjacent side is 1 unit. This is 90 degrees. Opposite side is 1 unit. Adjacent side is 1 unit. So hypotenuse will be, what will be the length of hypotenuse, children? We saw here. You got root 2. Now take a compass, children. Take a compass. Keep the point at 0. Then measure here, children, till this point. Let this point be P. Okay? And this point be A. OA is 1 unit. We drew 90 degrees line, perpendicular line 1 unit. AP is 1 unit. Then we joined points O and P. According to Pythagoras theorem, we got hypotenuse as root 2. Now take a compass and measure OP. Okay. Keep one point at O and keep another point at P. Now draw with this length point on the x-axis. Point on the number line. Where do you get, children? With this, take the length of OP and mark it on the number line. You get this point B. Means what did you do here? This OP length we took using compass and this OP length we marked it on x-axis. On the number line we marked it. We got point as B. That means this OP length and OB length are equal now. What will be the OB length? Root 2. And when you see this length is nothing but root 2. Now you got point B. You located point B on the number line. It will be here. It will be between 1 and 2. What did we do, children? We drew a number line. We marked 0, 1, 2 and so on. 0 is here. Is nothing but you can mark it as point O. Then at 1, it is 1 unit length. You marked it as A. At 1 unit, you marked it as A. And from this point A, draw a perpendicular of length 1 unit. Draw a perpendicular AP of length 1 unit. Then you got these two lines here. Now join O and point P. then it will become right angle triangle. You know that Pythagoras theorem. Hypotenuse square is equal to side square plus side square. Here OP is the hypotenuse of this right angle triangle OAP. Hypotenuse length you will get as root 2. H is equal to root S1 square, that is opposite side square plus adjacent side square. 1 square plus 1 square, that means root of 1 plus 1, you got root 2. So H you got as root 2. Now measure using a compass, measure the length of OP. Measure the length of OP and with this compass mark the point OP on the number line. You get the point B, that is root 2. This length only you are marking on the number line. So this root 2 you will get on the number line. So we located root 2 on the number line, children. This is the procedure. You should locate any irrational number on the number line. Let's solve example 4, children. Locate root 3 on the number line. What is the question, children? Next question, example 4. Locate root 3 on the number line. This problem can also be solved using Pythagoras theorem, children. So, first draw a number line, children. Draw a number line. 0, 1, 2, minus 1, minus 2. So, what did we do, children, to locate root 2 on the number line? We first, what did we do? This is 1 unit. 0 to 1, it is 1 unit. This point 0, assume it as O, point O. And this point 1, assume it as A, children. OA is 1 unit now. First, you should locate root 2. For locating root 3 on the number line, first step is locate root 2 on the number line first. That is, the procedure is same. I am telling the procedure is same. Okay, OA is 1 unit. Then draw a perpendicular. What should be the length of perpendicular, children? The length of perpendicular. Assume this point as B. The length of the perpendicular should be 1 unit. OA is 1 unit. OB should also be 1 unit. AB length also should be 1 unit. OA is 1 unit, children. And from A, draw a perpendicular line. A, B, and its length should also be 1 unit. Now join points O and B. Till this you know, children. What do you get now? You get the length of OB. How do you get? Using Pythagoras theorem. Using Pythagoras theorem, you get length of OB. See, children. OAB. What is the length of OA? It is 1 unit. AB is also 1 unit. According to the Pythagoras theorem, hypotenuse square is equal to opposite side square. Opposite side is AB. Opposite side square plus OA. OA is 1 unit. That is adjacent side square. Hypotenuse square H is equal to, this is H hypotenuse, H square is equal to opposite side square plus adjacent side square. You got 1 square plus 1 square. That is 1 plus 1. You get H square is equal to 2. H is equal to root 2. So children, you got OB. What is the length of OB, children? You got it as root 2. Now till now, you know this. If you want to locate root 2 on the number line, you take a compass, measure OB, and then what do? You will get here. This root 2 you will measure using compass and then draw on the number line. You get root 2. Now what do you want, children? You want what? Yes, you want to locate root 3 on the number line. How do you do that? Now, you got points OB, right? This OB is root 2. Now draw a perpendicular from B. Children, what should you do? You should draw a perpendicular from B and its length should be 1 unit. Take a protractor, children. Take a protractor and mark 90 degrees. That means you are drawing perpendicular. Okay. And the length of this should be also 1 unit. Draw a perpendicular here. Draw a perpendicular line to OB, and the length of this should be 1 unit. Mark the point as C. Now join O and C. Now join O and C, children. You got OB as root 2. At B, you draw a perpendicular of length 1 unit. Now this is root 2 and this is 1 unit, children. If you observe, children, this is also a right angle triangle. Triangle OBC. Triangle OBC is also a right angle triangle. Right angled at B. This is B. This point is A. This point is C. You got, what do you get, children? What did you get? You got OB as root 2 and BC as 1. This is also right angle triangle. You know that hypotenuse square is equal to side square plus side square. H square is equal to opposite side square is 1. 1 square plus adjacent side square. Adjacent side is OB, it is root 2. Root 2 square. One square is 1. Root 2 square is 2. So you got h square as 1 plus 2. H square is equal to 3. That means h is equal to root 3. Now you got the length of this hypotenuse h as root 3. What is the next step, children? You all know that. Now measure OC and using a compass measure OC and mark this on the number line. What do you do? From O, keep your compass at O, measure OC and mark this on the number line. You get root 3 now. Why did you get root 3 here? Because OC is root 3 and OC length only we marked on the number line. So you get root 3 here. This is the method you should follow to locate root 3 on the number line, children. Children, see, why did we take BC length as 1 unit? Why did we draw a perpendicular of length 1 unit? Because observe this, children. Root 2 square plus 1 square. Root 2 square is 2. 2 plus 1 you get as 3. H you will get as root 3. If you take some other value, root 3 here, root 2 square plus 2 square, the value will get changed. If this BC was length 2, you get 2 square plus root 2 square. That means you get 4 plus 2, you get 6. So if you want h square is equal to 6 you got here. Then h is equal to root 6. If you want to locate root 6 on the number line, then take BC as 2 units. Why did we take 1 unit here? Because we want root 3. We want OC length as root 3. When do you get OC length as root 3? Here root 2 is there. You keep in mind that you are using Pythagoras Theorem. That means root 2 square is 2. Only 1 extra you want. 2 plus 1, it will become 3. So you will take BC length as 1 unit. See, that's why we took 1 unit. If we took as 2 units, if BC length was 2 units, if we drew perpendicular of 2 units, you will get 4 plus 2. That is, you will get 6. H is equal to root 6 you will get. If you want to locate root 6 on the number line, then take 2. So according to the question, children, you want root 3 here. You got root 2 already here. So root 2 square is 2. 2 plus 1 will become 3. Then H you will get as root 3. So we took 1 unit here, children. So understand the question, children, properly. If root 3 is given, you take like this. If root 6 is given, you take 2 units. If something else is asked, according to that, change the length of the perpendicular you draw. Change the length here you take. Okay, children? According to the question, you do this. What do you do here? First, locate, draw a number line of length 1 unit each. 0 to 1 OA is 1 unit. Then draw a perpendicular of length 1 unit. Again, why? First we should locate root 2. 1 unit here and 1 unit here. That is, in a right angle triangle, adjacent side is 1 unit, opposite side is 1 unit. Then you get hypotenuse as root 2. Then use a compass and draw on the number line, you get root 2. Now it is not required. Root 3 is required. So you need not mark root 2 here to do root 3. You got root 2 here, OB. Then from point D, draw a perpendicular of length 1 unit. Why 1 unit? You should get root 2 square plus something square here as root 3. When you take 1 only, then only you get root 3. Because 2 plus 1 is 3. That's why you take 1 here. OB length as root 2. You Got. Then draw a perpendicular BC of length 1 unit. Okay. Then join OC. Then according to Pythagoras theorem, you get h square is equal to opposite square 1 square plus adjacent side square, that is root 2 square. H square is equal to 1 plus 2. You got h as root 3. Now using a compass measure OC, and with this compass only mark that point. Mark this OC point. Turn the compass and mark this on the number line. Then you get root 3. This is your answer, children. You marked root 3 on the number line. Children, now you know how to mark root 3 on the number line. To mark root 3 on the number line, first you should know how to find root 2 on the number line. That means to find root 3, we should first know how to find root 2 on the number line. Similarly, to find root n, that means any number, then we should know how to locate root n minus 1 on the number line. For root 3, you should know root 2. For root 7, you should know root 6. Similarly, for root n, you should know to mark root n minus 1 on the number line. Thank you for watching the video. Like, comment, share and subscribe.